Good afternoon, everybody. We have to be seen whatever part we have to be covered in the last lecture first, and then we have to be seen the another part, right? That I have to be given you, right? See, first we have to be seen the effect of input resistance RIF. Did you getting my voice? Please tell me. Did you getting my voice?
Yes, sir.
Okay. Effect of input resistance we have seen, we have covered this topic in our earlier session, but now we have to be revise the same thing, right? Voltage series feedback type of the amplifier, right? This type of the amplifier is also called as voltage amplifier. Now see, basically I'm telling you what do you mean by voltage amplifier, what do you mean by current amplifier, right? So the signal, the amplifier which should use the amplification with respect to voltage, that is called as voltage amplifier. The amplifier which should give the amplification with respect to current, that is called as current amplifier, right? See, we have to be seen now voltage series feedback type of the amplifier. This is also called as voltage amplifier, right? This diagram shows that the voltage series feedback type of the amplifier. I'm telling you something related to this diagram. See, we have applied the Vs as the input voltage to this type of the configuration, right? So Vs is the input voltage applied to the voltage series feedback type of the amplifier. At the same time, due to the application of Vs, there should be flowing of the current, that is I. This is called as input current, right? So this should be flowing through the device, that should be flowing through the resistance, that is a Ri, right? So current flowing through the Ri, that is called as Ii. So whatever the voltage, when we have applied the Vs as the input voltage, that is there is a input voltage, that is a Vi. Okay, so we have applied the voltage as the input Vs, that should be coming with respect to input. That voltage is called as Vi voltage, and current flowing through that Ri, that is a Ii. Okay, Ri indicate that input resistance of that particular circuit, right? This part related to the input network, right? So we have seen now part of the output network. Okay, so due to the application of Vs voltage, there should be generation of the input voltage, that is Vi, and the current Ii. So due to that, there should be generation of the output thing, right? So output have voltage, that is a Vi, that is also only coming with respect to output. But see, this is the amplifying network, right? So amplifier network have the gain of the AV is nothing but a voltage gain, right? So this is means output network act as a Vi, that is the input voltage with multiplying with the voltage gain of this circuit, right? So it is nothing but a Vi multiplied by AV. Okay, this should be act as a output, right? Okay, so it has some of the impedance with respect to your output. This impedance is called as RO or R0. Okay, so RI is the input impedance, R0 is the output impedance. Okay, whatever the current flowing when we are applying the into high voltage, in that case, that current flowing through the output, that's why it is called as I0 current, that should be flowing through the output resistance, that is RL. Okay, so that's why there should be generation of the output voltage, that should be called as V0. Okay, now we have seen the things such as so what happened, whatever the voltage coming across your output, that is V0. Okay, V0 is voltage coming across here, but it is a feedback network. Okay, so feedback network indicate that some part of output is again applied to the input. Okay, so Vf is nothing but that part of output is again applied to the input. Okay, this is the feedback. Okay, so we know that the value of feedback is nothing but a feedback factor into the output voltage. Okay, so we know that output voltage, that is a V0, and feedback is nothing, feedback network value is nothing but a beta. So your output thing, that is with respect to feedback thing, it is a Vf is equal to beta times C. This is also called as beta. Beta is nothing but a feedback network, and the V0 is output voltage, because output is again applied to the input. So beta into V0 is nothing but a Vf. Okay, Vf is nothing but a feedback. Feedback indicates that some part of output is again applied to the input. So it is a V0, and that feedback value is nothing but a beta. So Vf is nothing but a beta into V0. Okay, now see, in case of voltage series feedback amplifier, we have to be only done the analysis of this circuit. So analysis purpose, we have applied either your KVL or the KCL. So in this case, whatever the voltage applied, that only divided. That's why we have to use the KVL across it. Okay, there are two loops. This is input loop, this is output loop. Okay, so for that purpose we have applied the KVL to the two different loops. So initially we have applied the KVL to the input loop. So this is input loop, start up with the Vs, it is a positive, that's why it is as it is Vs. Then again we have traveling towards the II. Okay, this II is flowing through this Ri. Okay, so initial point is a plus, second point is minus. We are taking the minus point. Okay, second point, right? So Vs minus of this II flowing through the Ri. So it is nothing but a Vs minus of Ri into II, minus Ri into II. Okay, up to we have like over here. Okay, again we have going from here to the here. Okay, so plus, first point is plus, second point is minus. Okay, so it is nothing but a second point we have taken, so it is a minus Vf. Okay, so it is nothing but a Vs minus of Ri into I minus of Vf, which is equal to 0. This is the equation. Okay, now see, we have taking Vs on one side and taking this minus term on other side, so it changes its sign. Okay, Vs is equal to plus Ri into I plus Vf. Okay, this is the things. Okay, now we know that we have already know that Vf is nothing but a beta into V0. So wherever Vf is coming, we have put out as a beta into V0. Okay, so Vs is equal to Ri into II plus beta into V0. Okay, this is the thing as we have to be seen. Why we have to be putting Vf for Vf beta into V0? Because we know that Vf is nothing but a beta into V0. Okay, we just put out the same value here. So your value is Vs is equal to Ri into II as it is Vf beta into V0. This is nothing but equation number 1. Okay, now we have seen the things with respect to output. The output voltage is given by, now see, when we have to be seen, we have seen the things with respect to input. Now we have to be seen the things with respect to output. Now here are two resistors, that is R0 and RL. So in this case we have to be apply the, we doesn't apply here as an KVL, we have to be used as an voltage divider rule, because here two resistors are used. Okay, so for that purposes we have applying the voltage divider rule across it. So when we have applying the voltage divider rule, so it is nothing but a this resistance divided by both resistors into applied voltage. So it is nothing but a RL divided by R0 plus RL into applied voltage EV into Vi. So your, when we have applying the voltage divider rule, whatever the term coming across here, that is a RL divided by RL plus R0 into AV into Vi. Okay, why it is coming? Because when we have applying the KVL across in a circuit, so you, in that case, this resistance divided by both resistors into AV into Vi. This is the statement with respect to voltage divider rule. So RL divided by RL plus R0 into AV into Vi. This is coming when we have applying the KVL, that is VDR, that is voltage divider rule. Okay, so it is nothing but a V0 is equal to RL divided by R0 plus RL into AV into Vi, right? So in this case we know that when we have to be use the amplifier network, right? One of the important thing with respect to amplifier network is that whatever the output resistors coming across this configuration, it is near about 0 or it is a 0. So what happened? R0 in that case we know that R0 is 0. 0 indicate that see RL divided by 0 plus RL. So RL divided by RL. So its value is 1. Okay. So term which should be coming only here is AV into Vi. So V0 is equal to AV into Vi. This is the thing coming with respect to us. Okay. Now we have to be substitute whatever the term coming across your equation number 2, that should be substituted in equation number 1. Okay. Equation number 1C. Vs is equal to Ri into II plus beta into V0. Okay, we have write as a V0 here. See, Vs is equal to Ri into II as it is. Okay, beta as it is, beta into V0. See, beta into V0. For the V0, we know that value of the V0, it is nothing but a AV into Vi. So Vs is equal to Ri into Ii plus beta into phi 0. Phi 0 is nothing but a AV into Vi. We have put out AV into Phi here. Okay. So Vs is equal to Ri Ii plus beta into AV. Now see beta into AV, Ri into Ii. Why we have taking Ri into Ii? See, one of the reason behind Phi, we know that Phi equal to IR. Okay, so Phi is equal to R into I plus beta into AV into Phi. This is the equation, but we know that Phi equal to IR. Okay, IR indicate that in II into Ri. Okay, so for the Phi we have to be written as a, this is Ohm's law, Phi equal to IR. Okay, so Phi we have to be, instead of Phi we have to be written as a II into Ri. Okay, so your equation is Ri into II plus beta into AV. For Phi we have to be written as a Ri into I. Okay, now Phi is equal to Ri into I. Now we have taken out Ri into I as a common term, right? Ri into I as a common. So here 1 is remaining, 1. For beta into AV as it is, because Ri into I common. Okay, so term remaining is 1 plus beta AV only here, right? We have taken out Ri into I as a common. Okay, so Phi is as it is. Okay, this I we taking as a here, because this is multiply going here as a divided. So Phi upon I, which is equal to Ri into 1 plus beta into AV as it is. Okay, see, this is the thing. Okay, so Phi into II, it indicates that it is the input feedback resistance. It is nothing but a Phi upon I. It is R. Okay, Phi upon R equal to Phi upon I, Ohm's law. Okay, it is R. So this should, all the things related to the feedback amplifier. So this is feedback related. That's why we are taking F, and I indicate that input, right? So RF indicate that feedback input resistance. Okay, Ri into 1 plus beta V. What it indicate that whatever the value of the your input resistance with feedback, it indicate that your value of the input resistance. See, value of the input resistance, that is nothing but Ri, that should be increases by the factor of 1 plus beta AV when we have to be use the voltage series feedback network, right? So it indicates that the input resistance of voltage series feedback amplifier increases by this factor. This Ri indicate that it is nothing but a voltage series feedback network resistance. This increases by this factor, that is 1 plus beta AV factor, right? So when we have to use the voltage series feedback amplifier, in that case your input resistance is increases by 1 plus beta AV times. Okay, did you understand the same thing? This is the repeated part. Please tell me, did you understand? Please reply the लक्षात आलंय का?
Yes, sir.
Okay. Now we have to be seeing the current series feedback type of the amplifier, right? So what it indicates that, see, in this configuration we have to be use the current series network, which should show that whatever the part applied across your output, that should be coming with respect to input in a series, right? And that series we have to be use the term as an current, right? See, there are two network with respect to it, that is current network and the voltage network. But in this case we have to be use the series combination, and we have to be added the feedback as an current, right? So here one of the other thing with respect to coming with respect to here, that is nothing but a phi is equal to beta into, not phi 0, I'm telling you, beta into I0. Why it is, I'm telling you in a, when I am explaining the this equation, right? See, we have discussed with respect to the current series feedback type of the network, right? In that case we have applied the Vs as the input voltage. Please turn off mic.
रात्री बी मी होती तिथं म्हणजे माझ्या नावाचं चहा.
Okay, we have discussed the things such as current series feedback type of the amplifier, right? In this configuration we have discussing the things such as here we have applied the Vs as input voltage. Due to that Vs voltage is applied, there should be flowing of the current, that is II current, right? So due to the flow of II current, through the Ri, right? There should be generation of the voltage, that is a Vs voltage is applied. There should be generation of the input voltage, that is a Vi, that is the input voltage. Okay. Now this input voltage is flowing through the Ri, right? This should be related to the input, right? And again, this is the input network, right? This is your output network. So we have applied the Vs voltage. There should be generation of the input voltage. Vs is nothing but a input is applied. So due to that Vs input voltage is applied, there should be generation of the input voltage Vi and input current Ii, right? That should be flowing through the Ri. Okay, this part related to the input network, right? So due to that, there should be generation of the voltage, that is output voltage, right? So output voltage is nothing but this is a transconductor type of the amplifier, so it is nothing but a Gm into Vi. Input is applied to this type of the output network. See, this input is nothing but output for this type of the networks, right? Gm into Vi is coming with respect to output network, right? So in that case, current flowing through the output network, that is I0, and this should be flowing through the R0. Okay, now I0 is flowing also through the RL. Okay, this should be again applied to the input, right? So in this case, we have not applying any the voltage, we have applying the current, because this is the current series feedback amplifier, right? So I0 is coming across here, right? I0 is coming across here. So Vf is not here. See, beta into V0. It is a Vf is equal to beta. Beta is nothing but a feedback network, and whatever the feedback is coming, it is a I0. So Vf is equal to beta into I0. How it is? I am explain the things with respect to this description. Okay, so Vf is equal to beta into I0 in this case, because we have used output as a current. Okay, now we have applying the KVL to the input loop. Okay, this is input loop. So Vs minus of I into Ri. Okay, minus of I into Ri, and this term going to means Vs minus of I minus, because second point is negative, minus of I into Ri. So okay, plus minus, so minus of Vf. Okay, Vs minus of Ri into I minus of Vf, which is equal to 0. Okay, with respect to Vs, this negative going on other side, it is a positive. So Vs is equal to Ri into Ii plus Vf. Okay, now we know that, see here, we know that Vf is equal to beta into I0. Now the point why the beta into V0 is not came here across here, because feedback coming across here as a current, because this is the current series type of the feedback network, right? So that's why seen here. सी Vf is equal to बीटा इंटू I0. इथं चुकलं होतं, लक्षात घ्या. तेच इथं लक्षात घ्या, म्हणजे बीटा इंटू I0 लिहायला पाहिजे होतं, पण इथं ते बरोबर केलेलं आहे, लक्षात घ्या. ओके, so but Vf is equal to beta into I0. So wherever the Vf term coming, we have to be put out as a beta into I0. So Vs is equal to Ri into I plus beta into I0 plus beta into I0. This is equation number 1, right? The output current is given by, right? This will be the related to the input. Okay, now when we have to be seen the things with respect to output, this is the output loop, right? So in this case, we doesn't, there are two resistors, we doesn't applied here as an KVL. We have to be apply the voltage divider rule. Okay, when we have applied the voltage divider rule, it is nothing but a whatever the resistance, that is R0 divided by R0 plus RL into applied voltage. See, in this case, applied voltage is nothing but a Gm into Vi. So whatever, when we are applying the voltage divider rule, in that case your equation is R0 divided by R0 plus RL into Gm into Vi. See here, I0 equal to, so this voltage, right? This voltage, sorry, this current is nothing but a, this is not a voltage, this is a current. So I0 current equal to this, when we have applied the voltage divider rule across it, so it with respect to R0, it is nothing but R0 divided by R0 plus RL into Gm into Vi, into Gm into Vi. Okay, right? So in this case, see, in this case, when we have to be use the current series feedback type of the amplifier, we know that, see, in case of current series feedback type of the amplifier, when we have to be use whatever the output impedance coming with respect to it, it is a infinite. How it is, I'm telling you. See, Normally here is not value. See, I'm not telling related to it. See, when we have to be, when we have to be use the voltage series feedback type of the amplifier, in that case, whatever the value of the output resistance, that is R0, it is a infinite. This is the things, means हे लक्षात ठेवा, R0 is equal to infinite असतं, just current series feedback आपण use करतो. Okay, so we have put out here for R0 infinite, right? So infinite divided by R0, it is also infinite. Infinite from some value, it is also infinite. So infinite divided by infinite, it is a 1, right? So for the I0, we have only remaining is Gm into Vi. Okay, I0, because all the term R0 is infinite, so it also infinite. Infinite plus some value, it is also infinite. So infinite divided by infinite, it is a 1. So I0 is equal to Gm into Vi. Okay, we have to be put out wherever I0 is coming, we have to put out as a Gm into Vi. Okay, so substitute equation 2 in equation 1. So Vs is equal to Ri into I plus we have to be written as a Gm into Vi in this equation. Okay, so Vs is equal to Ri into I plus beta into Gm into Vi. See, beta into Gm into Vi. This is the equation, right? So Vs is equal to Ri into I, beta into Gm. We know that phi equal to IR. Okay, so this IR indicate that I indicate that input current, R indicate that input resistance. So your equation is Vs is equal to Ri into I plus beta as it is, Gm as it is, phi is equal to Ri into I. We have put out here. Okay, so Vs is equal to Ri into I because this is common between them. Okay, Ri into I taking as a common plus here Ri into I, here 1, that's why 1 is here, and other thing coming here is a plus beta into Gm. Okay, so Vs upon this I as a multiply going here as a divided, so Vs upon I, it is nothing but Ri into 1 plus beta into Gm. Okay, so phi upon I, it indicate that R. Okay, this thing related to the input, so Ri. Okay, this part is of the feedback amplifier, so it is nothing but a RIF. Okay, so it is nothing but a input feedback amplifier resistance. RIF indicate that input feedback amplifier resistance, right? So it is nothing but a Ri is equal to Ri into 1 plus beta Gm. What it indicate that when we have to be use the current series feedback type of the amplifier, this is nothing but a current series feedback type of amplifier. When we have to be use the current series feedback type of amplifier, whatever the value of the input resistance, that should be increased by 1 plus beta Gm factor, right? I'm again tell you, when we have to be use the current series type of the feedback network in case of your amplifier, in that case, whatever the input resistance value, that should be increases by 1 plus beta Gm factor. Okay, did you understand the things? Please reply that. लक्षात आलंय का? ज्यावेळेस लक्षात घ्या, ज्यावेळेस आपण पर्टिक्युलर कॉन्फिगरेशन अम्प्लिफायरची यूज करतोय त्यावेळेस पहिल्या कॉन्फिगरेशन मध्ये काय झालं होतं, त्याची व्हॅल्यू पहा. इन केस ऑफ युअर व्होल्टेज सिरीज फीडबॅक अम्प्लिफायर, याच्यामध्ये काय झाली होती, तुमची RIF ची व्हॅल्यू ही 1 प्लस बीटा फॅक्टरने इनपुट इम्पिडन्सची वाढली होती. सेम थिंग इथं सुद्धा इनपुट इम्पिडन्सची व्हॅल्यू 1 प्लस बीटा Gm फॅक्टरने वाढलेली. अकॉर्डिंग टू व्हॉट एव्हर द इनपुट अप्लाइड, इट शुड बी चेंजेस. ओके, लक्षात आलंय का? प्लीज रिप्लाय द्या.
येस.
ओके, माझं म्हणणं काय, 2 पॉईंट राहिले ते संपवायचे आणि त्यानंतर आज संध्याकाळी 5:30 नंतर टेस्ट टाकतो मी त्याच्यावर. ओके, नॉर्मली वेळ खूप कमी आहे तुमच्यासाठी. 4-5 तारखेला एक्झाम चालू होणार आहे तुमच्या. त्यासाठी आपण काय करणार आहोत, नॉर्मली लास्टचा चॅप्टर 3 लेक्चर मध्ये होईल जास्तीत जास्त. तर मग आजच्या लेक्चरला हा टॉपिक स्मॉल 2 पॉईंट आहेत ते संपवूया. त्यानंतर आज संध्याकाळी टेस्ट टाकतो याची. ओके, आणि नॉर्मली तुमची देर शुड बी पॉसिबिलिटी 25 तारखेपासून IC2 असेल. ओके, see we have seen the term, that is effect of bandwidth on bandwidth and gain, right? Effect of bandwidth and gain, right? That is the factor. Now see what do you mean by bandwidth, what do you mean by gain, right? I'm initially explain what do you mean by both term, then I have to be explain this type of the configuration, right? Bandwidth indicate that range of frequency over which your device should be work. I'm again tell you, bandwidth indicate that range of frequency over which your device should be work, right? I'm explain the same definition with respect to this diagram, right? Then I am explain the second term as an gain, right? See, bandwidth indicate that range of frequency. Range of frequency indicate that, see, we just consider as an audio amplifier, right? It should be worked from your 0 hertz to the 20 kilohertz. You know that 0 hertz to the 20 kilohertz, right? So this is nothing but a 0 hertz to the 20 kilohertz. It is the range of frequency, okay, right? 0 hertz to the 20 kilohertz, it is the range of frequency of your audio amplifier. Did you understand? Please tell me. We have, I am more elaborate with respect to the definition of bandwidth, right? Bandwidth indicate what? See, bandwidth indicate that range of frequency over which your device should be, or your amplifier should be worked. Okay, now we have to be discussed the one of the type of the amplifier, that is audio amplifier. So in case of audio amplifier, their range of frequency is 0 hertz to the 20 kilohertz. Okay, normally 0 is not considered the 20 hertz to the 20 kilohertz. It is the range of frequency. Okay, so what it indicate that, 1 minute. सर लेक्चर चालू आहे, थोड्या नंतर कॉल करतो. सर लेक्चर चालू होतं, लेक्चर चालू आहे एक अर्ध्या तासात. ओके. See, the effect of bandwidth and gain with respect to we have to be discussing. In this case, we have discussed what do you mean by the bandwidth, right? This indicate that range of frequency, this to the this. If it is considered as a 0 hertz, 0 hertz is with respect to input. This indicate that 20 kilohertz, right? So audio amplifier is a range from 0 hertz to the 20 hertz, 20 kilohertz, right? So the range of frequency over which your amplifier is worked, that is called as bandwidth. Okay, for audio amplifier, range of frequency is 0 hertz to the 20 hertz, or it is also called as 20 hertz to the 20 kilohertz, right? So bandwidth indicate that bandwidth म्हणजे काय असतं की ज्या रेंज पर्यंत तुमचा अँप्लिफायर वर्क करतो, नॉर्मली तो 0 टू द 20 किलोहर्ट्ज या फ्रिक्वेन्सी पर्यंत वर्क करतो, लक्षात घ्या, त्याला म्हणायचं बँडविड्थ, राईट. मग त्यानंतर सेकंड डेफिनेशन आहे गेन, राईट. वी हॅव डिस्कस्ड द टर्म विथ रिस्पेक्ट टू गेन. गेन व्हॉट इंडिकेट दॅट? गेन इंडिकेट दॅट इट इज द रेशो ऑफ आउटपुट टू द इनपुट, राईट. सो we are discussing the relationship with respect to bandwidth and gain with respect to the feedback, right? Feedback indicate that some part of output is again applied to the input, right? So in case of frequency response or diagram of the two different thing, right? This is the frequency response without applying the feedback, right? Frequency response without applying the feedback, right? What it indicates that we doesn't apply any feedback, that is positive or negative, any type of the feedback. So when we doesn't apply any type of the feedback, here is a gain, right? Here is a gain, here is the bandwidth, right? See the diagram. When we are not applying the feedback, right? Frequency response without feedback, right? In this diagram, we doesn't apply any feedback, right? So when we are not applying the any feedback, in that case, gain of the amplifier, here is the gain, right? Gain of the amplifier is more, see, more, and the range of frequency indicate that bandwidth, it is a, see, less, right? So in case of your amplifier, when we are not applying any feedback, in that case gain is more and the frequency is less, right? Then another thing, as an when we are applying the feedback, see, feedback indicate that some part of output is again applied to the input, right? So in that case your response is such a way that, right? So when we have used the feedback, in that case whatever the gain that should be reduces. See, in this case, it is a more, right? In this case, it is a less. But one of the other thing, that is with respect to bandwidth, it should be increases, right? From here, it should be increases. From here also, it should be increases, right? So concluding thing with respect to this type of the production of the gain and the bandwidth is that, see, when we have not using any type of feedback, in that case, your whatever the gain, see, when we have not using any type of feedback, in that case your gain is more, but whatever the range of frequency, that should be less, right? So what it indicates that when we have uses not any type of feedback, in that case your gain is more and the range of frequency, it is nothing but of bandwidth is less when we have not using the feedback, right? When we have using the feedback, when we have to be using feedback, in that case your gain is less. See, your gain is less, but range of frequency, it is nothing but a bandwidth is more. Okay. दोन वाक्य मराठीत सांगतो, लक्षात घ्या. जर आपण एखाद्या अँप्लिफायरला जर आपण फीडबॅक यूज केला तर त्याला काय होतं, गेन कमी होणार आहे, पण तुमची ऑपरेटिंग बँडविड्थ आहे ना ती वाढणार आहे. पण ज्यावेळेस आपण अँप्लिफायरला एखादा फीडबॅक यूज करत नाही, त्यावेळेस काय होणार आहे, त्याची गेन वाढणार आहे, पण त्याचा रिस्पॉन्स जो आहे, म्हणजेच तुमची बँडविड्थ आहे ना ती कमी होणार आहे कम्पेअर टू याच्यापेक्षा. ओके, हे लक्षात आलंय का? रिलेशनशिप लक्षात येत आहे का बँडविड्थच्या रिस्पेक्ट टू आणि गेनच्या रिस्पेक्ट टू? प्लीज टेल मी. आणखीन एकदा सांगू शकतो मी, जर लक्षात नसेल आले तर प्लीज टेल मी. लक्षात आलंय का? मी सांगतो एकदा, लक्षात घ्या. आपल्याला इथं काय पाहिजे, सी, वी हॅव टू बी सीन द थिंग्स दॅट इज रिलेशनशिप बिटवीन युअर बँडविड्थ अँड द गेन, राईट? Means you have to be use the feedback or you are not using the feedback, right? When we have to be use the feedback, see the term, right? When we have to be use the feedback, right? So this is the diagram. See, this is the diagram when we have to be use the feedback, right? So in this diagram shows that here is a frequency, here is a gain, right? So in this diagram, when we have using the feedback, in that case range of frequency means start up with here, right? Range of frequency start up with here and end up with here. Compared to this, it is a more, right? But with respect to gain, in case of your gain with the feedback, right? Gain with feedback here, gain without feedback is here, right? According to that, two things we have to be seen. When we have to be use the feedback, in that case gain value should be reduces, and another thing happen, that is a range of frequency, it is nothing but a bandwidth, it should be increases. Okay, and in case of your frequency response without feedback, when we have not using any type of feedback, in that case your gain, here is a gain, it should be more than that of this configuration. So when we are not using any feedback, gain should be increases, and the operating frequency indicate that bandwidth, it should be decreases, right? So two things we have to be seen here. When we have to be use the feedback, in that case gain should be reduces and the bandwidth should be increases, and when we are not using the feedback, in that case gain is increases but the bandwidth should be reduces. Okay, आता सांगा, लक्षात आलंय का? Please
Yes,
tell.
sir.
Okay. Now we have seen that sampling and mixing in case of feedback amplifier, right? So what do you mean by sampling and what do you mean by mixing, right? That I'm telling you. So mixing indicate that some part of output, see, some part of output is again applied to the input, that is mixed with, means some part of output is again applied to the input, it is nothing but a mixing, right? Mixing indicate that output signal is again mixed with respect to input, right? So it is called as mixing, right? There are two types of the sampling and mixing with respect to this type of the configuration, right? So using sampling network, we sample the output voltage or output current, right? There are two things, right, with respect to sampling, right? So which thing you have to be sampled? See, sampler indicate that we have seen the different type of the configuration, that is voltage, voltage type of the voltage series, voltage shunt, current series, current shunt, that are the type of the different network, right? So in case of sampling, what we have to do, accordingly, there are two things with respect to your sampling. Sampling indicate that some part of output is again applied to the input, right? So some part of output, it is either your voltage or current, right? So accordingly, it have two types of the sampling. One is your voltage sampling and other is your current sampling, right? In case of voltage sampling, we have applied the input, accordingly it should be generated output, right? So generated output as an voltage, right? That generated output voltage is again applied to the input, right, as a voltage. Then that sampling is called as voltage sampling. That is sample the signal is voltage, right? What it indicate that we have applied the input as a voltage, accordingly output generated it also voltage, again it should be applied to the input as an voltage, right? So sampler, this is nothing but a sampler thing. So sampler thing, it is as an voltage, right? That's why when we have to be sampler as an voltage, sampler indicate that we have taking the part of, when we have taking the part of output as an input to this type of the network, then it is called as sampled voltage network, right? So in case of sampled voltage network, we have applied the input as a voltage, we have got as a output voltage, we have again that output voltage is applied to the input as an voltage, right? So this is nothing but we have sampled the output voltage again to the input. That's why this is called as voltage sampling, right? So in case of current sampling, we have applied the signal, either your voltage or current, it doesn't matter here, right? We have applied the signal in this case as an voltage or current. Accordingly, there should be generation of the output current. See, output current, right? That output current is again applied to the input through the feedback network, right? So we have to be sample out this output current and then apply to the input, right? So we have sampled the output current. That's why this is called as output sampled current signal, right? So it is called as sampled signal, which should be coming here. It is a current, right? I'm again explain these two things, how we have to differentiate the sampling of the voltage and sampling of the current, right? So in case of sampling of the voltage, what we have to do, we have to be apply the input, accordingly generated the output, right? Whatever the generated output we have taken as an voltage, right? As we have to be taken as an voltage, that voltage is again applied to the sampled voltage. This voltage is called as sampled voltage. This sampled voltage is again applied to the input. When we have to be sample out the voltage from your output, then that network is called as samplers. In that network is called as sampling of the voltage, or this signal is called as sampling of the voltage signal. Okay, now we have seen the things with respect to the another network, that is a current, right? We have applied the any signal, that is voltage or current. Accordingly, there should be generation of the amplified signal. That amplified signal which should be formed across here, it is a current, right? That current signal is applied to the feedback through the feedback network to the input part, right? So this should be called as sampling of the current. That's why here whatever the signal sampled, that is a current, right? So in case of voltage sampling, we have to be sampled the output voltage. In case of your current sampling, we have to be sample the output as a current. That is the only thing we should be coming with respect to this. Okay, now we have seen the mixing network now, right? Mixing means what? Whatever the input applied, accordingly output should be generated, right? That output is again applied to the input. So applying output to the again input, it is nothing but a output mixing with respect to the input. Did you understand? Mixing indicate that mixing network indicate that we have applied the input. See, we have applied the input, consider here, we have applied the input, accordingly output should be generated, right? So applied application of input, output is generated. That output is again applied to the feedback network. Either it is connected to the input part as in a series or as in a parallel. There are two types of the mixing network, that is a series feedback network or the shunt feedback network, right? So in case of series feedback network, what we have to do, we have applied the input signal, right? We have applied the input signal to the amplifier network. right? This is the block diagram, right? We have applied the input signal to the amplifier, right? Accordingly, there should be generation of the output signal. Whatever part coming output, that part is again applied to the feedback network, right? So feedback network part again applied to the input with respect to series. That's why this type of the feedback is called as series feedback. In case of series feedback, whatever the output coming, that should be added with respect to input in a series. That's why this is called as series feedback type of the network. Okay, now we have seen the another part, that is a shunt type of the feedback network. Okay, now see, shunt type of feedback network, what we have to do, we have applied the input signal, right? Input signal is applied to the amplifier. Amplifier amplifies the signal, that again output is coming across amplifier, right? That whatever the output coming, that output is again taken as an parallel, right, to the feedback network, right? So feedback network again, it should be provided to the input network in a parallel. Parallel indicate that this part connected to this network in a parallel, right? So in case of series feedback network, whatever the output sample, that should be sent in respect to the input in a series. In case of shunt network, whatever the output sample, that output is again applied to the input in a parallel, right? That is the only change with respect to us. Okay, did you understand the concept? Now I'm telling something related to this topic, right? Sampling and mixing. What is the difference between sampling and mixing, right? So sampling indicate, what do you mean by sampling? Same thing. लक्षात घ्या, सॅम्पलिंग असेल किंवा मिक्सिंग असेल, सेम तर थिंग होत आहे तिथं. पहा, ज्या सॅम्पलिंग असेल, सॅम्पलिंगला काय करतोय आपण, आउटपुटचा पार्ट परत तुम्ही इकडं फीडबॅकला अप्लाय करताय, लक्षात घ्या. ते अजून इकडं अप्लाय करत नाही, लक्षात घ्या. सॅम्पलिंग करताय म्हणजे काय, आउटपुटचा पार्ट जो आहे ना, तो सॅम्पल म्हणजे पार्ट ऑफ त्याचा घेऊन आपण फीडबॅक नेटवर्कला प्रोव्हाइड करताय. म्हणजे when you have to be considered as a sample signal, in that case part of output is applied to the feedback network only, we doesn't it applied to the amplifier, where we have to be considered as a sample thing. लक्षात घ्या, सॅम्पल थिंग म्हणजे काय असणार आहे, आउटपुटचा पार्ट आहे ना, तो सॅम्पल करतोय आपण, सॅम्पल करून तो तुमच्या फीडबॅक नेटवर्कला प्रोव्हाइड करतोय, लक्षात घ्या. त्यावेळेस ते तुमचं सॅम्पलिंग सिग्नल असतं. आयदर ते कुठल्या टाईपचं सॅम्पल सिग्नल, जर म्हणजे पार्ट ऑफ आउटपुट जर ॲज अ व्होल्टेज घेत असेल ना, तर ते असतं सॅम्पल सिग्नल, इट इज ॲज अन व्होल्टेज, राईट. आणि पार्ट ऑफ आउटपुट म्हणजे ते अप टू द फीडबॅक नेटवर्क पर्यंत असतात. जर पार्ट ऑफ आउटपुट जर आपण सॅम्पल करत असो आणि तो इन द फॉर्म ऑफ करंट असेल अप टू द फीडबॅक नेटवर्क, त्यावेळेस त्याला म्हणायचं सॅम्पल सिग्नल, इट इज ॲज अन करंट, राईट. हे झालं सॅम्पलिंग. म्हणजे ज्या सॅम्पलिंग येतं ना, त्यावेळेस पार्ट ऑफ आउटपुट आपण अप टू द फीडबॅक नेटवर्क पर्यंत कन्सिडर करतो, लक्षात घ्या. म्हणजे सॅम्पलिंग करतो त्यावेळेस पार्ट ऑफ आउटपुट आपण अप्लाय घेतो आणि तो फीडबॅक नेटवर्कला अप्लाय करतो. वी डजंट अप्लाय इट इन अ इनपुट नेटवर्क. ओके, नाउ इन केस ऑफ मिक्सिंग नेटवर्क आपण काय करतोय सांगतो. पार्ट ऑफ आउटपुट बाय डिफॉल्ट आपण कन्सिडर केलाय, म्हणजे पार्ट ऑफ आउटपुट अगेन अप्लाय टू द इनपुट, म्हणजे ऍक्च्युली सॅम्पलिंग झालंय, लक्षात घ्या. ऍक्च्युली सॅम्पलिंग झालंय, ते सॅम्पलिंग झालेलं जे आहे ना, सॅम्पलिंग झालेल्या नेटवर्कला आपण इनपुटला अप्लाय करतोय, लक्षात घ्या. इनपुटला अप्लाय करतोय, ते इनपुटला अप्लाय करताना आयदर इट इज सिरीज मध्ये असेल किंवा इट इज अ पॅरलल मध्ये असेल. म्हणजे जर ते सिरीजने अप्लाय केलं असेल तर त्याला म्हणायचं मिक्सिंग ऑफ दॅट सिग्नल इन अ सिरीज. ओके, पॅरलली अप्लाय केलं असेल तर मिक्सिंग ऑफ दॅट सिग्नल इन अ पॅरलल, दॅट इज अ शंट. ओके, कन्सेप्ट लक्षात घ्या. सिरीज आधीच पहा, सॅम्पलिंग म्हणजे काय करत होतो आपण, फक्त पार्ट ऑफ आउटपुट घ्यायचा तर फीडबॅक नेटवर्कला अप्लाय करायचा. पण इन केस ऑफ मिक्सिंग मध्ये काय करत होतो, पार्ट ऑफ आउटपुट टू द इनपुट हे बाय डिफॉल्ट केलेलंच आहे आधी, फक्त ते आउटपुट फीडबॅक नेटवर्कला जे आलेलं ना, ते इनपुटला अप्लाय करणं, त्यावेळेस तुमचं मिक्सिंग नेटवर्क असतं. म्हणजे सॅम्पलिंग म्हणजे फक्त पार्ट घेणं आणि फीडबॅक नेटवर्कला देणं. मिक्सिंग म्हणजे काय, पार्ट ऑफ आउटपुटचा घेतलेलाच आहे, आधीच घेतलेला आहे, तो फक्त तो आउटपुटला अप्लाय करणं, ते म्हणजे मिक्सिंग झालं. लक्षात येतंय डिफरन्स बिटवीन मिक्सिंग अँड द सॅम्पलिंग? प्लीज टेल मी. नसेल लक्षात आलं तर मिक्सिंग आणि सॅम्पलिंग परत एकदा सांगतो, प्लीज सांगा लक्षात आलंय का?
येस सर.
ओके, दिस इज द एंड ऑफ चॅप्टर नंबर 6. एक चॅप्टर राहिला, नॉर्मली 3 लेक्चर मध्ये होईल, तो सोपा चॅप्टर आहे तो. नॉर्मली त्याच्यामध्ये क्लास ए बी म्हणजे अम्प्लिफायरचे डिफरंट टाईप आहेत ऑडिओ अम्प्लिफायरचे, तेच पाहणार होतो त्याच्यामध्ये. आज 5:30ला जर माझ्या लक्षात नाही आलं तर प्लीज मला सांगून द्या की टेस्ट आहे, कारण की मी सध्याला 1 मिनिट.